Hey everyone, welcome back. I know it's been a time since I've been back, and I really want to thank everyone for being so patient with me. You may know that I started my job at BugCrowd, and then I changed teams at BugCrowd, and I was kind of doing both jobs for a while to kind of cover. So I've been doing a lot of extra work, which has meant I haven't had a lot of free time to do videos. So I'm really sorry. I've also been really sick. I've been in hospital as well. But I'm doing better now, and that's why you're getting videos. So today I'm going to cover a topic that I think a lot of people want to know more about, but potentially you probably already know a lot about. This isn't for you. So this week we're going to be talking about Bash scripting, and specifically the very beginning of getting people into Bash. Now I know a lot of people will be really familiar with Bash and be kind of Bash advocates. This is not the video for you. Though if you have people who are interested in learning Bash, this is the video for them. So I'm really going to be talking about today how to use Bash and how to start automating your bug bounty process. And we're going to look at ways of kind of creating Bash glue to put a bunch of recon tools all together. This video is of course very kindly sponsored by Integrity. Integrity is a fast growing bug bounty platform. So they have, your targets, they have the kind of reporting functionality, and then they also pay out for bugs. So because they're growing fast, there's actually quite a lot of opportunity there. So there is always new programs, always scope changes. There's plenty of really fresh things to hack. And not only do they have kind of fresh things to hack on private programs, they also have fresh things to hack on public programs, and they send you this little email that kind of goes over changes, so you can really keep up to date on your targets and what they're doing. I really like working with them because they're huge supporters of the bug bounty community, sponsoring not just my content, but other creators as well. I know a lot of people have already signed up, and even some of you have found your first bugs or participated in the XSS challenges or have won swag, and I'm really, really happy for you all. If you also want to join them and sign up too, you can use my link on screen. That's go.integrity.com/Katie. It's also in the video description as well. A sponsorship really helps me invest more into the channel, so I really hope you give them a lot of love from my community to theirs, and I'm approaching them because I really do think they provide something great. Now I'll talk about money. I know it's been a long time since I've been back. I know that a lot of people have probably been waiting for this video for a while. So what I'm going to do to kind of give back to you for being so patient with me over these last few months is a monthly giveaway. So this month I'm going to be giving away 1 lifetime membership to bugbountyhunter.com, 10 InsiderPhD swag packs, which will have some of my stickers, but also stickers from Portswigger, like burp stickers, and I've got some Integrity stickers as well, depending on kind of what's in stock. Any kind of free stickers I get, I'll just put into those. 5 1-month memberships to Pentester Lab Pro, and also 5 2-month premium Try Hack Me vouchers as well. So if you'd like to win, and this is something where you'd I would like free things, thank you. So to win, on this video, comment below with the answer to what bug or type of hacking do you want to know more about. And the text #bounty please. This just allows me to actually filter out all the comments really easily for people wanting to enter. This won't be the only video that will have this giveaway. I'm going to be doing more videos this month, so every single week you'll have a chance to win, but there'll be a new question. So for this week, comment on this video, what type of bug or hacking do you want to know more about, and the text bounty please. I will announce the winners in the community tab by the end of the month. So what is Bash? So Bash is kind of basic programming in the command line. I'm kind of putting quotes around basic because it's actually really powerful, really powerful. I think a lot of people think that it's just for kind of mocking up small scripts, but actually it can do a ton of putting together a bunch of things. So it's usually on Linux, but also on OS X. I'm going to be demonstrating this on Kali Linux because I think that's probably the Linux distribution you most likely have, but it will work on any Linux distribution, also on Macs, also with the Windows Linux subsystem. All of this will run bash scripts. And you can do a ton with bash. Like, it is so flexible and so powerful. But you really do need to know some basic concepts about programming. So in this video and in my next video, I'm going to be going over kind of some basic programming concepts and how you can do them in bash. So this is really, really useful if you're already using command line tools, because every single time you use the command line, you're actually using bash. You're just kind of doing it one line at a time. So if you're already using command line tools, kind of putting that together in a script can really become this kind of glue that ties together a bunch of automation. So some things you may be familiar with: Nmap, FFUF, lazy recon. You might be familiar with way back URLs, with like other recon tools. So quite often recon tools are written in the command line to be as flexible as possible. So with bash, the idea being is that you can sit there and kind of create all these little scripts that can all do things. Now, in addition to this, there's also tools that can do things like parallelize bash scripts, like interlace, or run it across multiple servers. And so there's quite a lot of also like further architecture, which makes it really great because it means you can go and build up these like automation pipelines over time. So let's kind of talk about the basics. How do we run a bash script? So I'm going to be using Nano in all my demonstrations today because it's easier. So the first thing we do is we create a file. In this case, it doesn't matter what it is. Bash scripts traditionally end in .sh, just because they do. We then have this, once we kind of create a file here, we then have, this is the text that goes in the file. So this first line is called a shebang, and it basically tells like the shell what kind of file it is. So you can see here it's a bin bash file. And then we've got the first command, which is echo hello world. We then have to run this command over here. And this is because we want to make the file executable. So chmod will change the file permissions. And what we're adding is this +x, which means add executable, to this file name. And then finally, by doing this starting and then the file name, we can run it. So creates the file, all bash scripts will end in .sh, that's how you can recognize them. We then get the first line of the bash script is our shebang. It tells bash how to read it. Echo will print a value out. We then need to use chmod to change the file permission, so we can change the read, the write, but what we're looking for here is the execute. Now, if you've kind of getting errors with bash, it's usually that you haven't made the script executable. So just make sure you always do that, or you've messed up the shebang at the top. And it really just tells the shell that this file can be run, not just like read. So our // means in the current directory. So we're running the file called filename.sh in the current directory. This means we can kind of create our bash files anywhere and access them from anywhere. And that's it. And then just a reminder that that is our shebang. We always need that at the start of our bash scripts. It's not optional. You really do need it. Okay, so let's go do a demo and go create a basic hello world script. So I'm going to be switching over to Kali and kind of demonstrating this. Okay, and we should be back now. That's a very basic bash script, but it really shows kind of how you can kind of get started with them. And every single demonstration I'll be doing today will follow this same structure. So you really can do this fairly quickly. So the first thing you should know is how to write a comment. code, and any kind of code really, can get complicated really quickly, and especially if you're making scripts that you'll run once and then probably won't for a little bit, and then you'll run it again. So maybe you've got a recon scripts, you'll spend some time, running the recon, but then at the end, you go, okay, that's me over, and then you won't run it for months afterwards. By adding comments, you can kind of just remind yourself how something works, and I like to put whether or not you need to know something. So to do a comment, you use the kind of number button, and it can either be on a line on its own, as in, if I just get my little laser pointer, as in this one up here, or it can be at the end of a line, as is here. So it's really your choice what would work better for your code, but you can see when we do an echo hello world, we don't actually see the comments. Now, my suggestion with comments would be to comment big blocks. So when you're doing something like, I don't know, runs nmap and does a basic scan, by just writing that at the very top of like 5 or 6 lines, you can kind of easily figure out, what line might be broken, for example, what function is broken. But also if you want to change how it works, you can change it. So next thing to look at is variables. So variables lets you set a value as like words and then change the value. So if we look at the example here, we change our variable here, which is when we assign it, has the value of value in a string. We can echo it, so hello, and then we do a $sign variable. So this will then echo our value. And then this next line here will then echo out again. Then later on we can change it, so variable becomes new value, and then we can echo it out the same way we did before. So you can see here that we've got value, then new value. So the idea being here that we can reassign the variable, give it a different value later on, or if we're doing something like something more complex, maybe we're loading in a file which has a bunch of lines of loading another file which has a bunch of lines with our, say, domain on it, all of our targets. Well, we might want to make it so we write like a generic find subdomains function, and then we might use variables in that case. And you can also not just store kind of the raw data in a variable. You can also store results from commands, but we'll go over that soon. So it's really useful to be able to do this. It gives your code quite a lot of flexibility. And if you're already familiar with programming, this will probably become quite naturally to you to kind of make more generic functions. When we program, one of our kind of goals with it is to make or to write code which is quite abstract, so we can use it for a lot of different things. So that way we don't have to write code multiple times. So the next thing is math or arithmetic or adding numbers together. So it's quite easy to do maths in Bash. So you can see here that we can just echo out a $sign and then brackets and then put in whatever we want to do there. You can do your standard maths. You can add numbers, divide numbers, take away, times numbers. You can do modulo numbers, so that is to do a division and then get the remainder. So 9 divided by 3 is obviously 3. But if we want to do, 10 divided by 3, we actually have 3 remainder 1. So that grabs the remainder. We can increment and decrement numbers, so increase it by 1 or take 1 away. We can also do the exponent or the power of, so 2 to the 4, for example. It's the usual suspects. If you're already familiar with programming, you'll probably already know quite a lot of this, but it does have a slightly weird way of working. So down my second example here, you can see we use variables for x and y, and all we do is we kind of do $sign parentheses, and then we do x plus y, and that will give us the we'll assign that to the variable answer. So then we echo out x plus y equals answer. So 5 plus 10 equals 15. This is the literal string here. So not like doing the maths. So this line does the maths, this one here. And this is just the literal string to kind of make it nice for users. Speaking of users, we can also add user input. So you might already be familiar with this idea of using parameters. So what we do in bash scripting is we kind of have parameters like this. So we have our file name and then the parameter. So to access these, they're denoted with kind of 1, 2, 3, etc., etc. You can have as many parameters as you want. And you can see up here we can do echo hello world 1. So what that's going to do is print out whatever we have as my parameter. So in this one we get hello world my parameter. And this is just, basic kind of stuff. Simple things you usually use this for, maybe you want to provide file input. So let's say you're creating a tool where you've listed a bunch of subdomains already. And what you're trying to do is take screenshots of every subdomain. So you have another tool that does that. So what you might want to do is you might want to include as your parameter the list of subdomains. Or maybe you have a more complex file system and you want to look in a folder and then you've got some other logic. This is how you can kind of supply that user input. There's another way to supply user input, which is essentially to tell them kind of, okay, here, do, here's everything. Now, what do you want to do? 1, 2, or 3? And I'll show you how to do that soon. Or you can kind of make them parameters. Parameters tend to be the most common way of doing things in kind of Linux world, because then they can run unattended without somebody being there to kind of watch over them. Now, you'll notice that these are variables. So the same way we do variables before, and what I showed you earlier is they work the same way. And we can also, from this, get output from commands. So here we've got a bin bash, and we can actually assign a variable to be the command who am I. So that is a Linux command which says whoever you're currently running the files as. But you can include anything there. Like, let's say you want to run an nmap scan, you can get the results there. Let's say you want to get some information from, or send some information to FFUF. That's where you could put it. And you can kind of see it working there, that if we run the file as sudo, we can see hello world root versus like this one where we're getting the parameter. So you can kind of see we can start to customize this a little bit. So you can see on this one, that kind of echo hello world 1, we could put in whatever we wanted as the parameter and it would still echo it. And down here you can see, our variables. The same way we saw variables before is how these variables work as well. And by adding a separate command, we can run that separately. So let's have a play around with these kind of concepts we've discussed here. So I'm going to open up the demo. So we're going to have a look at kind of our comments, variables, adding that user input, and also doing some basic mathematics. So I'm going to flip over to the demo and I will see you shortly. Okay, and we are back. So in our demo, we're often using echo, and echo is really useful. It prints stuff to the console. But when we start to play around with different data types, so let's say we want numbers as well as strings, we need to kind of do things a bit differently. So we're going to be using something called Printf, which is print formatted. And the idea is that in our text here, we can kind of tell it what kind of data type to expect. So a string, which is just text, an integer, which is a whole number, and a float, which is a floating point number which has a decimal point in it. So we can do a bunch of things here: change precision, pad numbers, set widths. There's a ton of things we can do with these. So if we look at this top example here, you can see we've got printf value 1, and then we've got this %s, and then value 2 %s. So once we do a printf, the next things we do on that same line are then the two, or whatever we want to include. So you can see here we're expecting 2 strings, so we've got 2 strings, which is hello and world. So the value that gets printed to the console down here is hello and then world. But then we still print out that entire string in one go. This is really useful when you start to deal with really long outputs, because it means that you're not having to like have different echoes and mess around with things. You can kind of do things in one go. And then in our second example down here, we have printf value 1, and we change it from an S to an I. And then we also have value 2, which is changing from an S to an F. So we will have a I for integer and an F for floating. So we provide first a 1, so that's our integer value, and then 3.14, which is our float value. So then we have value 1 of 1 and value 2 of 3.14, blah, 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 blah. So this is really, really powerful for kind of leveling up our kind of basic printing functions. And when you start to look at how many options there are for like printf and all these different data types, it can be a bit overwhelming. So my kind of general advice is to, if you've got to print on one line multiple variables, you probably want to use printf rather than echo. But echo will do the same thing. Now let's talk about functions. Now I said before, one of the kind of key concepts of programming is this idea that you should be able to reuse code. And in programming, copying and pasting code is actually seen as quite bad practice. So functions let us reuse code, but without copying and pasting it. So this is the syntax we need to use. So we use the word function and then whatever we want the name of the function to be. So I've just called this one name. Then we have open brackets and then close brackets and then curly brackets. Now, what does that actually mean? Well, the curly brackets refer to like our what that function can take in as input. But don't worry too much about this because you can actually use parameters like this as well. So what does this do? This just echoes out hello world. If we want to use that function later on, we then have to just call it without the brackets. So in a lot of programming languages, especially if you're used to like C syntax style, you actually have to include the brackets every single time. But with functions in Bash, you actually don't have to. You can just do name and then it will run hello world. And the same syntax here, you know, we add a parameter. So if we run the script with a parameter, it will say, if we run the script as a parameter, we can also run this as a parameter as well. So we have name and then the space and then whatever the value is going to be. And that will print out hello Katie. If we want to change this, we can just add to it, essentially. So that kind of $1 is then equal to Katie. But don't worry, we'll do it as like, I'll show you how it works. It's very difficult to explain programming, like in general. because it's quite difficult to explain it. But this is really, really helpful because you can imagine you can have like a big long script and still be copying and pasting like the code that outputs something. Functions let you kind of put all of the related code all together so you don't have to worry about it. So the next thing we might want to do is send commands to a file. Now, when you perform any command, you actually have kind of quite a lot of choices. You can output to a file, you can append a file, or you can send it to another tool. Now, this is true of all Bash, and I'll speak more about it in a moment. But this includes both your scripts, but also when you run something in the command line. So by using this, we can output to the file. So that just puts whatever the output of that script was going to be into the file, just shoves it in there. We can append to a file. So that means we don't delete what was there before, we just add to it. Now you can kind of imagine potentially if you're running a script, you might actually want to append a file for maybe each domain that you run it on. You can imagine that you might want to do this for something like recon, especially where you kind of never want to lose anything, but maybe there's some instances where if you get no results, you don't want to output it. And you can send it to another tool, and this is really useful if you run any of Tom Nom Nom's tools, for example. I've put his GitHub repos in the description because he's got a ton of really useful quick tools. This can be super useful. So one of his tools is Gron, which basically lets you easily deal with JSON files. And the way that works is that you can essentially run one command that gets, say, for example, an API, and then send it to Gron to then deal with it kind of further tooling. And this is, I think, one of the simplest, but yet the most kind of useful thing that Bash does. It provides a lot of these like standard input and output functionality where you can send stuff onwards to other tools. Now, the general rule of Bash in terms of like moving from kind of running single lines to running scripts is that if it works in the command line, it will work in Bash functions. It will basically work for anything, right? Anything that works in command line can be copied and pasted into a Bash script, including things like nmap, including things like ffuf, including like anything that you would usually just run standalone. The more difficult thing comes if it then expects user input. So if you've used Metasploit, you might know that you need to you run nmap, you then go search for the essentially the POC. But then you have to choose which POC to use. And because you kind of have to be interrupted, that does make it more difficult to use. But as a general rule, if it works in the command line with one line, it will work in Bash. Now, right now, our code runs one line at a time. And that's useful. Like, it's good to know what comes next. But sometimes you want to control the flow of our program. So that means we maybe want to do multiple things or do a logical test. So we control this with decisions and loops. So decisions, or an if statement or if else, means that code only runs if a condition has been met. So what that means is, let's say you're doing you might have seen it in like something like spreadsheets. If the value is greater than a certain value, make the cell red. If it's higher, make it green. Same idea. If something, then do something else. So that's our decision. We then have a loop. So a loop means that code runs until a condition isn't met, which is a bit confusing. So essentially, we're asking it constantly, is this value greater than or less than or equal to something else? If it's not, run the code again, etc. Now, in Bash, we also have kind of conditions. Conditions are statements of logic. They can only be true or false. There's no other one it can be. Now, you might be familiar with the kind of mathsy logic version of these, so I've put them on one side, and then we have the test command. And test is like a specific bash tool, but that's what we use. So we have a version of greater than, equals to, not equals to, less than, and you can kind of see over here, 1 is 1 greater than 12, no, so it's false. Is 1 equal to 12, no, it's false. Is 1 not equal to 12, then it's true. And if 1 is less than 12, that's also true. So you can kind of see we've got a limitation here of true or false. Now, conditions in Bash aren't actually just limited to numbers. You have access to so many conditions in Bash. You have conditions about strings, so are two strings equal? You can sort them. What is the length of strings? We have files. Does the file exist? Is it a file or directory? Is it readable? We have shell, so like the actual script itself. Is a variable set? Does it have a value? We have brace expansion and directories and a whole bunch of them. I'm not going to really go over them. You can kind of look them up on your own time. But there's a ton of really useful things you can do with conditions in Bash. And actually, in a lot of ways, sometimes writing something in Bash is even quicker than writing it in something like Python, because a lot of these conditions are like super easy to actually write. So with that in mind, let's do if statements. So if statements broadly allow you to do something different depending on whether or not a condition has been met. If that, then do this. Else if this, then do this instead, or else do something else. An else if lets you set this kind of additional condition, but you don't need it. Something to note is that if statements are read in order, so the first statement that is true will be run and everything else gets skipped. So the Bash way of doing this is if space square bracket space condition. Now, you have to make sure you have the spaces in the correct places, otherwise it won't work. So if condition, and then we have a next line has then, and this will run if the condition is true. We can then do an else if and specify a second condition. And if that one's true, then we can echo out true. But these conditions don't have to have anything to do with one another. They can be completely different. And then we also have an else. So this is kind of, if nothing else is true, this will run. And we end with phi, which is the reverse of if. So we start with if and we end in phi. Now, this is kind of difficult to understand, and I really do appreciate that. So let's kind of go over ifs a little bit and how they work. So I'm going to go back into our demonstration here, and I will see you in a moment. Okay, that was a really simple version of an if statement and how you can get one working in practice. By the way, for all of these little scripts, I've included a GitHub below which has all the examples in, so if you just want to see how the code is written, you can see it there. Now, we also have case statements. So case statements are similar to if statements, but they allow different code to be run depending on the value of a single variable rather than many. So, for example, if the variable has the value 1, do this. If it has the value of 2, do this. So if you want to kind of do a menu style, this is how you'd make a menu. So we can see here that we've set our variable to be the first parameter. So we can do a case variable in. So this sets up the case statement, and this is the variable name. And then these are our values. So if our variable has the value of 1 or 2, then we run this line, and note it ends in 2 semicolons. If it has the value of 3, we can do a bunch of other stuff down here. Notice that also these can be multiple lines. You don't have to restrict yourself to one line, but each one must end in these semicolons. We can also add a default case. So this means if nothing else was true, we'll use this one. So here we've got like a star, echo, something else, and then the 2 semicolons again. So when you see bash scripts, sometimes you'll see like additional parameters that you can have that change how the code is run as kind of like a menu. This is how they work. So each one of these will usually be a link to a function that will then run that particular thing. So, for example, you can kind of imagine, you are doing, for example, you either want to do a port scan, or you want to, if you have, like, say, for example, port 80 open, you might want to then do a kind of directory brute forcing. So this is how you could do something like that. And notice that it ends down here with InsiderPhD, so that's case backwards. So starts with case forward, case backwards ends it. So let's kind of go through this and kind of how it works. So this I think is quite difficult to understand, but it really is useful for adding interactivity to your programs. So I'm going to go start up this demonstration. I will see you all in a moment. Okay, so case statements, as you can kind of see, is kind of a bit more confusing, but they honestly are so useful for controlling the flow of programs. Now we have loops. So loops are kind of the second way to control the program flow. There are 2 main types of loop, a while loop and a for loop. A while loop will run until a condition is met, and a for loop will run a number of set times. So it usually has a counter, which says, okay, run this 5 times, run this 6 times, etc. So the real difference is whether or not you know how many times that has to run. If you don't know how many times it has to run, you want a while loop. If you do, you want a for loop. General way of looking at it. So a for loop can have many conditions to run. I'm going to talk primarily about running the for loop an X number of times. So the bash syntax is the number you start with, ... and then the number you end in. So this is saying run this starting at 1 until it's 5. So we start with do and we end in done. Why don't we start in odd, end in odd, sorry, which is do backwards? I don't know. So essentially this allows us to make this run 5 times. Now the other syntax you have is like this one. Start at 0, end in 10, but go in jumps of 2. So start, end, increment, start, end. If you're familiar with Java or some of C syntax style programming language, you might be familiar with this instead, where you have your value of I, then your condition, and then the increment. This is another way of doing things that just allows you to set the condition and also set the increment. It works the same. There's no real difference between the two. But primarily you use a for loop when you know the number of times you want it to run. Now, what if you don't know the number of times you want it to run? Say, for example, you're loading a file. Well, you want a while loop. So as I said before, a while loop runs until a condition has been met. It can be used the same way as the for loop. So this is a while loop here. So while x is less than 5, we're going to print out the value welcome, x times, and we do x at the very end, we do an increment, so x is equal to x plus 1. Now this is basically a for loop. We have the setup, the kind of condition, and then the increment. But really, the most common one is reading a file line by line. This is just a quick way of doing it. So while read our line, so this will read every single line, echo the line, and then done. So each line is processed, in this case echoed, and you can add from this, like read more complex files like .csvs if you're processing data, for example. So let's have a look at what this looks like in practice. So I will get the demo up and we will take a look there. Okay, this I realise is quite a long video all about how to do some really basic bash scripting. So what I've also included in the description is some additional extra pieces of code, and what this will allow you to do is a bunch of like general kind of patterns. So reading from a file, you can use this code. So you can see here that we just run it by line. So each new line is a new line, and you can see that I've used this to open up loops here. And text read from file, whatever. We can read from a CSV. So here you can see we set the value of col1 and col2. Now, essentially what this allows us to do is use a separator. So this is kind of similar to our last one, apart from we can see here col1, col2 is then our variables, and we can echo that out. we can check if a file exists using a basic if statement. So by doing if and then -f output.txt, we can echo out file exists. That's really useful if you're trying to figure out whether or not to make a new file or append to a file. Super useful to know that. If you want to write to a file, you can use this syntax, and you can see here that we can echo out a variable to an output. Really useful if you're trying to build up the kind of recon pipelines where you're trying to, say, get some output. Maybe you're doing, I don't know, you've got a list of targets, then you're trying to find subdomains, then you want to save it on because you want to then run that subdomain through wayback URLs, for example. You can use this code. You can combine expressions by using logical statements. So you can see here, if output.txt exists and it's equal to something else, then do this. So you can use this one, which is and, 2 bars, which is or, and an exclamation point, which is not. So with an and, both conditions must be true for something to happen. So you can see here that if our second parameter here is equal to test here, we get file exists. Otherwise, if it's just te, we get nothing because it's not also equal to test. If we change that to an or, it would run if either one of them are true, so it would run. And not just does the opposite. So if one part of your condition returns true, it will return false. Kind of more complex things here. This is an example of using kind of the separate commands. So you can see here we can compare 2 hashes of 2 files and see if they're the same. And we can just know if they're equal. We can use wget to get stuff from the internet, for example. But I will say that this is like not even scratching the surface of what Bash can do. I highly recommend looking at some like Bash tutorials and walking through it and having a go, because it is an amazing tool for doing scripting, and particularly to put, if you've already got like different processes you already run, I highly recommend taking a look at this and just trying to automate it. It's so useful. You can also use cron jobs, and that's something we're going to talk about in the future, to make things run, say, every day or every hour or every week. So you can start to implement continuous monitoring. So that way you're not just hacking what you see at any one point in time, you're kind of comparing the differences to what it was, say, a week ago to what it is now, and highlighting those differences for yourself. And that is the end of the video. I hope that you found that interesting, informing. I've put all of the code in a GitHub repository below that you will be able to download and kind of try out for yourself. Actually, I highly recommend following along with demonstrations instead, because you will learn a lot by just doing and having a play around with it. So thank you again to Integrity for sponsoring my content. I really don't take having an advertiser on my channel lightly. I really genuinely think they do amazing things for the community. It really has allowed me to make serious investments into my channel. For example, the audio, the editing, being able to do giveaways. I really like the fact they interact with their community and the wider bug bounty community. They are always replying to hackers, so give them a lot of love from my community to theirs. You can sign up with my link on screen, go.integrity.com/Katie, or in the video description if you'd rather have a link. Do not forget about our monthly giveaway. So if you would like to win either of these prizes, so we've got 1 lifetime membership to bugbountyhunter.com. We have 5 2-month Try Hack Me premium vouchers, 5 1-month memberships to Pentester Lab Pro, as well as some swag packs with stickers provided by myself, but also by Portswigger, who make Burp, and Integrity. And to win, You need to comment on this video with an answer to the question, what bug or type of hacking do you want to know more about? And the text bounty, please. At the end of the month, I will be putting in all of the names into a big old raffle, and then I will choose people at random to win these prizes. But if you don't win on this video, don't forget there'll be videos every single week this month, so you'll be able to watch those and then enter. So thank you very much everyone for watching, and I will see you all next time. Bye everyone.